Let's study the arrangement of electrons in an atom according to the Niels Bohr's theory. Electrons are negatively charged particles and they are said to be arranged in the clouds of negative charges around the nucleus. In this cloud, the electrons are arranged according to their potential energy in different energy levels or shells as proposed by Niels Bohr. The energy levels of the electrons are denoted by the numbers 1, 2, 3, 4, 5, 6, and so on. And these are represented by the letters K, L, M, N, O, P respectively. Means the first energy level is K, second is L, third is M, fourth is N, and so on. Keep in mind, you cannot change the sequence of these letters or the numbers. As in the picture you see the nucleus positively charged pink sphere around which the spheres are formed in the form of circles in which electrons revolve. They are represented as K, L, M, and N letters. The numbers are mentioned below the letters 2, 8, 18, and 32. These are represented as the number of electrons in these shells. How they are calculated, this you will study in the next video. Let's understand an example first. This is a model of oxygen atom. As you know, the number of electrons, protons, and neutrons are 8 in the oxygen atom. Means 8 electrons, 8 protons, and 8 neutrons. So at the center, 8 red spheres and blue spheres are there. 8 red and 8 blue. These are 8 protons and 8 neutrons. Plus around it, in the sphere, in the circular paths, there are 8 green balls which are representing the electrons revolving in the outside the nucleus. In first orbit you see 2 green balls, means 2 electrons can be there, and in outside in the second orbit there are 6 green balls, that means 6 electrons. Total would become 2 plus 6 is equal to 8. How this arrangement is done, this we are going to study in the further videos. I hope you have understood how the electrons are arranged in an atom now. Let's study the rules of arrangement of electrons in the orbits. The first rule says the maximum number of electrons which can be accommodated in any energy level of the atom is given by 2n square. Here 2 is the number and n means the number of the orbit. For example, like k is the first, L is the second, M is the third, and so on, and the square of that number. The second rule says the outermost shell of an atom cannot accommodate more than 8 electrons, even if it has the capacity to accommodate more electrons. For example, like if an atom has the outermost orbit, that is third orbit, and it has 9 electrons left out, but it can have only 8 electrons in the outermost orbit and the left out one will go in the next orbit. The third rule says electrons in an atom do not occupy a new shell unless all the inner shells are completely filled with electrons. Means unless the first orbit is filled with 2 electrons, the next orbit will not have any electron. In the second orbit, unless the 8 electrons are filled, the electrons will not go in the third orbit, and so on. Let's understand these with some examples. Let's understand how the electrons are arranged in the given orbits. The formula is given as 2n square, where n represents the number of the orbit or shell. So let's understand one by one. For the value of k orbit or shell, k is the first orbit. So number of electrons in k energy level would be equal to 2 into 1 square, that is 2 into 1 is equal to 2. For the next energy level, that is L, second energy level, 2 into 2 square means 2 into 4 is equal to 8. The number of electrons can be in the second orbit, 8. The third energy level, M, the number of electrons in it will be equal to 2 into 3 square, So 2 into 9 is equal to 18. So in third orbit, number of electrons can be 18. For the fourth energy level, that is n, the number of electrons would be 2 into 4 square, that is 2 into 16 is equal to 32. So in this way we know that number of electrons in the first orbit can be 2, in the second can be 8, in the third can be 18, and in the fourth can be 32. So let's understand this with an example. Let's study the arrangement of electrons in an atom by an example. This is a sample problem in which it is asked to write the electronic configuration of element X whose atomic number is 12. So when we do the electronic configuration, in the first orbit we know that the maximum number of electrons can be 2. In the second orbit 8, and then rest will go in the third orbit. So 2 plus 8 plus 2 will become equal to 12. 2 plus 8 plus 2, because in the first orbit maximum number of electrons can be 2, in the second 8, and the rest go in the third. So on the right hand side you see the pic in which at the center it is mentioned 12 protons and 12 neutrons in the pink circle. Then in the first orbit 2 electrons, in the second orbit 8 electrons, and rest 2 electrons in the third orbit. So in this way we do the arrangement of electrons in an atom. In the given table, you see the electronic configuration of first 10 elements of periodic table. In the first column, element name is mentioned. In the second, its symbol. In third, its number of electrons, that is its atomic number. Then the electrons are mentioned in the first, second, third, and fourth shells. And in the last column, the electronic configuration is written. Similarly, let's see the electronic configuration of next 10 elements from 11 to 20. These are the next 10 elements from sodium to calcium. You see again the atomic number, first, second, third, and fourth shell orbit electrons, and in the last column the electronic configuration. In this pic, you see the atomic arrangement of electrons in the various orbitals of first 20 elements of periodic table from hydrogen to calcium. The next topic which we are going to study is valency. Just like elements have symbols, compounds too have symbolic representations known as its formula. Before writing its formula, we must know its valencies of each element present in them. So what is the valency exactly? The definition of valency says that it is the combining capacity of an element. What is the combining capacity? It is that how many bonds can an atom form by sharing, by losing, or gaining of electrons. This you will study in detail in the different classes. Here we will study the general term about valency, like capacity of an atom to give, accept, or share electrons to achieve the octet. Octet means the last orbit must have 8 electrons to gain the stability of an atom. Like in the first, on the left hand side, you see the first atom is hydrogen. It has only 1 electron. It needs 1 electron for its duplet to be completed, and its valency is 1. Similarly of oxygen, it has 6 electrons in the outermost orbit. So oxygen requires 2 electrons to complete its octet, so its valency is 2. Similarly, other elements also have different valencies for completing their octet and to achieve their stability. Let's have a look in the table of different elements and their valencies. In this table, you see the valencies of the mostly used atoms. Please learn them for the further convenient uses.